All right, today we're talking about quadratics. Now we're going to talk primarily about gathering information from a quadratic equation and then how to graph it. So it will be very, very helpful if you have your notes from class because I'll be referring to some things. I'm not going to be able to show every piece of the notes, but I will be referring to them. So if you have your notes, it'll make life go a lot easier, okay? Now, there's a lot of information they're asking about this one equation. Now notice I've given you the standard form of a quadratic here because I'll be referring to A values, B values, and C values, okay? So before I even start using standard form, I'm going to identify my A, B, and C. My A in this problem is -1. Notice it's the coefficient for the squared term. B is -6, coefficient for the linear term. And my C is my constant of -9. So knowing these three terms, I'm going to first go through the instant information, okay? The stuff that I look and I know. We call it the look and know, all right? Immediately I know this opens down, okay? This is in your notes. If A is negative, it opens down. So right away, I just got an answer. Second thing I know, the y-intercept. It's just your C value. And it makes sense because if you think about it, to find the y-intercept, you make the x 0. Well, 0, 0, you're only left with a C value. So my y-intercept is 0, -9. Keep in mind, you don't see any work right now. I haven't had to do anything. It's the look and know part. All right, I'm gonna have to work for the axis of symmetry. I'm gonna have to work for the vertex. I'll have to work for the reflection of the y-intercept. I'll have to work for the x-intercept. We'll talk about this in a second. Min or max. Now, you don't know the value min or max, but you do know right now, this is a parabola and it opens down. There it is. If it's opening down, then my vertex will sit at the top of my parabola, making it a maximum value. So, because A is negative, immediately I know I open down and I have a max value. Last piece that's an instant look and know, domain. Think about it, parabolas, they continue going in each direction, negative infinity, infinity. So if you have a problem like this in a test and you leave it blank, that's so stupid. Look how much information you get from just looking at an equation. 1, 2, 3, 4 points, and you didn't do anything. Come on now. You know how to look at 1, 2 values, and you got 4 points. All right, now let's get into some work. Now, the axis of symmetry is where I recommend my students go next. This is found, now keep in mind, it's x equals. That's not to tell you a value. That's because it's the equation of a line, okay? We're going to use this as an equation of a line. X equals -b over 2a. So, plug in my values. Careful here. -b value. Well, the b's already negative. Okay, then it will become a positive over 2 times a. So my axis of symmetry is x equals -3. It's not -3. It's not just a random number. It's not a point. It's not a value. It's an equation of a line, okay? So we'll come back to how we're going to use this. So this serves two purposes. First off, it's going to tell me the axis of symmetry. It's the line that all my points will reflect around. But it also serves as the x value for my vertex, okay? Now to find my y value, I plug x into my original, okay? To find my y value of the vertex, I plug my AOS value in for x to the original. So I'm going to do that real quick. Be careful with all the negatives here. Negative x value squared -6 times my x value -9, okay? -3 squared is 9. Remember, I do the exponent first, then the negative. So this will give me a -9 because -3 squared is +9, negative waiting for it. -6, -3 gives me a +18 -9. Well, this one worked out pretty well. This, if you add them all together, gives you 0. So my y value for this vertex is 0. So now I know my vertex is -3, 0, and my AOS is x equals -3. So let's plot this point, okay? I go to -3, 0, and I put a dotted line representing my AOS. Now, I'm going to be using this to reflect points around, okay? Now, I also have a point of 0, -9. Might as well use it. Here's how my reflection works. If it is truly a line of symmetry, it means you can fold something directly onto itself. Low battery, we're back. So, if I am 3 to the right, symmetrically, I will be 3 to the left. Now, this is going to start helping me see my curve, but it also answered another question. The reflection of the y-intercept. Well, there's my y-intercept. I reflected it to this point. That's the point -6, -9. And I just got another answer. Okay? Now, from here I am going to use a chart just to get my next 2 points. Now, when I tell my students, I always throw my vertex in there first, and then I just go 2 to the right. So if my x is -3, the next point going to the right would be -2, followed by -1. I just go 2 to the right of my vertex. To find my y values, I have to plug them in. Okay? So, to find this y value, I plug in -2 to the original. So it's -2 squared -6 times -2 -9. We're going to do a little mental math. -2 squared is +4. Throw a negative on it. -4 plus 12 minus 9. Notice we get a -13 plus 12. That's -1. -2, -1. Again, I can reflect any point I plot. If I'm 1 to the right, I know the reflective point is 1 to the left. Now, you can technically stop here. I only require 5 points. But just to demonstrate this skill one more time, I'm going to plug in -1. Again, it's only going back in for an x value to the original. So it'll be a -1 squared -6 times -1 minus 9. Again, every time I pick an x value, it's plugging back in to the original. -1 squared is 1. Throw the negative on it again. -1 plus 6 minus 9. My negatives give me a total of -10 plus 6 gives me -4. So I go to -1, -4. I'm 2 to the right, so I go 2 to the left. I now have a very good idea. I see the curve. I be the curve. And I have my actual parabola. Now, last 2 things. And again, additional points, you can see those here. X-intercepts, we're going to be solving this. But that will be the last thing I'm going to do. And you can already see it sometimes on the graph. But the range is y values. So I look least to greatest, because we're doing interval notation. It doesn't stop going down. So I know my smallest is -infinity. Goes all the way up, 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 and stops there. Now we're talking y values, so the highest y value is 0. And we hit that, so it's an actual bracket. Highest y value. You know what's a synonym for that? Maximum. Oh, I didn't forget. They want to know the max value. Well, the max value is what's the highest value. This one goes all the way up to 0. The max is the y value of your vertex. The min will be the y value of your vertex. The y value of your vertex always tells you either your max or your minimum. All right, last thing, x-intercept. Now, you can tell from the graph on this. You can look and you know that we're going to come up with -3. But let's say you didn't. Then you're just solving this. Now, we've looked at factoring. You can also use quadratic formula. You can also use completing the square. We primarily use factoring in class, so I'm going to show that right now. To find my x-intercept, I'm going to take my original and set it equal to 0. So I have a -x squared minus 6x minus 9 equals 0. I never like factoring with a -a value, so right off the bat, I'm going to multiply everything by -1. Leaving me with x squared plus 6x plus 9 equals 0. It's a very, very nice factor problem, leaving me with x plus 3 equals 0. Solve both of these quantities, you get -3. So it just has the one x-intercept of -3, 0. I know that was a lot, There's a lot of work to be shown, so don't try and tell me you did it in your head. That's exactly how you would work through graphing a quadratic, gathering information about every piece. All right, hope it helps.